Hello viewers, welcome to the section Signals and Slots. In this section we will learn about writing a simple application, using stacked layout in Qt applications, writing a simple maths application. Now we move on to the video, writing a simple application. In this video we will understand how to support events in our application. We will see a simple application with just one button. When the button is clicked, check whether we can print something on the console or not. First, we will see our code in the mydlg.h header. This is our entire code. We declared a class with the name mydlg. It inherits QDialog class. Then we declare one button pointer. Here, we declare our QHbox layout pointer, and then we declare our constructor. Go to mydlg.cpp file. Here, we have defined the mydlg constructor to add a single button to our dialog window. In line number 22, we instantiate the QBox layout. Then we instantiate the QPushButton with the message "Click me." In line number 26, we add our button to the layout with the help of the addWidget method. With the help of this setLayout function, we apply a layout to a widget. Then we set window title as Signals and Slots. Let's go to our main.cpp file. Every Qt GUI application must have exactly one instance of the QApplication instance. QApplication provides support for command line switches for our application, hence the need to supply the argument count and the argument value. GUI-based applications are event-driven, so they must respond to events or, to be precise, signals in the Qt world. In line number 25, we declare an instance of mydlg constructor. In the next line, we call the show function on mydlg instance. In line number 28, the exec function starts the event loop, which ensures the application waits for the user interactions until the user closes the window. Let's build and run our program and later add support for signals and slots. Go to our terminal and run the qmakeproject command. It will generate our ex1 profile. Then execute the qmake command. It generates the make file. Now we have to go back to our Atom editor and make some changes in the ex1.profile. Click on the ex1.profile. After the include path line, add Qt plus equals widgets. Let's go back to our terminal. Run the make command that will build our project. After that, execute our binary executable file using the / command. As you can see, we have successfully obtained the Signals and Slots application. Let's stretch this window. If you click on the button, you will notice that nothing happens, as we are yet to add support for signals and slots in our application. Okay, it's time to reveal the secret instruction that will help you make the button respond to a button click signal. Hold on, it's time for some more information. Don't worry, it's related to Qt. So let's explore which signals QPushButton supports before we write any further code. Let's make use of the Qt Assistant for API reference. The QPushButton class section gives loads of useful information, such as the header file name, which Qt module must be linked to the application, that is, QMake entries that must be added to .pro and so on. It also mentions the base class of QPushButton, that is QAbstractButton. If you observe the content section, that seems to cover public slots, but we don't see any signals listed there. That's a lot of information. If the content section doesn't list out signals, QPushButton wouldn't support signals directly. However, maybe its base class, that is QAbstractButton, would support some signals. Scroll down further. If you observe the highlighted section under Additional Inherited Members, apparently the Qt Assistant implies that QPushButton has inherited 4 signals from the QAbstractButton. So we need to explore the signals supported by the QAbstractButton in order to support the signals in QPushButton. Let's click on QAbstractButton. With the help of the Qt Assistant, it is evident that the QAbstractButton class supports 4 signals that are also available for QPushButton, as QPushButton is a child class of QAbstractButton. So let's use the clicked function signal in this exercise. Let's go to the Atom editor. We need to make some minor changes in mydlg.h in order to use the click signal. We need to add 2 header files. First add QDebug. As you are aware, the QDebug class is used for debugging purposes. It offers functionalities to Qt applications that are similar to cout, but they aren't really required for signals and slots, We are using them here just for debugging purposes. In line number 33, write private slots. And in line number 34, write void on button clicked. It is our slot function that we are intending to use as an event handler function that must be invoked in response to the button click. Let's make changes in my dlg.cpp file. Now we will add a new code after line number 30. Let's understand what this code means. If you observe line 40 to 42, the onButtonClicked method is a slot function that must be invoked whenever the button is clicked. But unless the button's click signal is mapped to the onButtonClick slot, the Qt framework wouldn't know that it must invoke onTheButtonClicked function when the button is clicked. Hence, in line numbers 32 through to 37, we have connected the button signal clicked function with the myDLG instances on the button-click slot function. The connect function is inherited by myDLG from QDialog. This in turn has inherited the function from its ultimate base class called QObject. Okay, let's build and run our program and see whether the signals work in our application. Let's go back to our terminal and close the Signal and Slots application. Clear this screen using the reset command. We must build our program using the make command. Now run our program using the // command. As you can see, we have successfully obtained our result. Let's stretch the application. Interestingly, we don't get a compilation error, but we get a warning message. This is a hint from the Qt framework that we have missed out on an important procedure which is mandatory to make signals and slots work. Next, go to the Atom editor. We need to make some changes in the mydlg.h file. After line number 25, we need to add QObject. Any header file that has the QObject macro that hints to the QMake utility that it needs signal and slot support. Hence, we must use the QObject macro in our mydlg.h header file. Once the recommended changes are done in the header file, we need to ensure that the QMake command is issued. Let's go to our terminal and close the application. Now clear this screen, list our files, then run the QMake command. After that, execute the make command. Let's understand just what happened. When we run the QMake command, the QMake utility will open the ex1.pro to get our project headers and source files. When QMake passes mydlg.h and finds the QObject macro, it will learn that our mydlg.h requires signals and slots. Then it will ensure that the mock compiler is invoked on the mydlg.h so that the boilerplate code can be auto-generated in a file called mockmydlg.cpp. This will then go ahead and add the necessary rules to the make file so that the auto-generated mockmydlg.cpp file gets built along with the other source files. Now that you know the secrets of Qt signals and slots, go ahead and try out this procedure and check whether your button click prints the button clicked message. We will go ahead and build our project with the changes recommended. Now it's time we test the output of our cool and simple application that supports signals and slots. So, execute our program using the // command. The output is presented here. When you click the Click Me button, it prints the button clicked message. Congratulations, you can pat your back. You have learned enough to do cool stuff in Qt. In this video, we learned to write a simple application.